Okay. If you have three terms and the coefficient is not 1, you have to make a times plus chart. Remember that when you make your times plus chart, the times comes from multiplying A times C. The plus comes from B. Remember that when we factor trinomials, they're written in the form ax squared plus bx plus c, okay? If the problem has 4 terms, then you're going to group it. You're going to factor by grouping, okay? Once you get your factors, always look at your factors and see if you have a difference of 2 squares inside of there, okay? Because if you do, you're going to have to factor it again. So let's look at this first example. So first, GCF. Yes or no? Is there a GCF in this? What is it, Tessa? I'm going to take out a 4. When I take out a 4, I'm left with x squared minus 1. How many terms do I have? How many terms do I have? 2. That means I need to check and see if this is the difference of 2 squares. I have 2 terms. Is x squared a perfect square? Yes, it's made by taking x times x. Is 1 a perfect square? Yes, it's made by taking 1 times 1. So I'm going to put a plus in one of the parentheses and a minus in the other. And don't forget to bring down your 4. What do you think? Okay with that? Okay. The next example. How many terms do we have? So what does that mean that we should probably check? Yeah, see if this is the difference of 2 squares. Is x to the 4th power a perfect square? How is that made? X squared times x squared. Is 81 a perfect square? How is that made? 9 times 9. Okay. Can we factor this anymore? Which one? Yeah, the x squared minus 9 is also the difference of 2 squares. Do you guys see that? So this does not change. I'm going to leave the x squared plus 9 the way it is because I can't factor that with integers. But the x squared x squared minus 9 is also the difference of 2 squares. So how do I get x squared? I get that by taking x times x. How do I get 9? 3 times 3. Join one with a plus, one with a minus. This is now completely factored. We okay with those? All right. Example number 3. So how many terms does example number 3 have? 4 terms. So if I have 4 terms, I already know that I need to group them, right? So I'm just going to put some little groupies around there, some parentheses. What common term can I take out of the first grouping of parentheses? Take out an x squared. That leaves me with x plus 2. Notice in the next parenthesis, my leading coefficient is negative. We rarely allow that to happen. So I need to take out a -1, right? Taking out a -1, let's see, negative x divided by -1 gives me a positive x, which is what I need. -2 divided by -1 gives me a positive 2, which is also what I need. So this factors out to x squared minus 1 times x plus 2. Are we done? Yeah? No, why not, Tessa? Yeah, x squared minus 1 is also the difference of 2 squares. That factors out to x plus 1 times x minus 1. And then don't forget about your x plus 2 on the end. I don't know if I can move that up because that's a little sloppy. Without, no. Okay, well, I can't really shift that any more than that, so we'll just have to do our very best to see the next problem. Okay, what about this next example? How many terms are there? So I know it's going to be a grouping, but do you see a GCF in there? What is it? 7? 7y. Everything can be divided by 7y. I think you guys do better when I write it like that. So I'm going to take out a 7y. What's left? Well, let's see. 7 divided by 7 is 7. Y divided by y cancels out. So the first term is just going to be x cubed. Negative 7 divided by 7 is negative 1. Y's cancel out, x squared. 21 divided by 7 is 3. The y's cancel out, x. 21 divided by 7 is 3. So that's a negative 21, negative 3, and the y's cancel out. How many terms do I have now? 4. So I'm going to group those. Do you guys see how I just did that? So I still have to keep my 7 out front, right? That 7y is still part of the problem. So 7y. Greatest common factor here is x squared. So I'm going to take out an x squared, and that leaves me with an x minus 1. What can I take out in the second parenthesis? A plus 3, and that's going to leave me with an x minus 1. So let's see what we really have. We really have 7y times the repeated term, x minus 1, times x squared plus 3. Can I factor that anymore? Can I factor the x squared plus 3 at all? Is that the difference of two squares? No. Okay. So we're done. All righty. Let's go to the next one. 3 terms. So I know I'm going to have to use a times plus chart. However, before I go doing that times plus chart, I'm going to see if there's a GCF. Does this have a GCF in it? What is it? I'm going to divide everything by 3. I'm just going to put that 3 right down here. So maybe I don't forget about it later. So let's see. That gives me x squared minus x minus 20. So when I do my times plus chart, I'm looking for two numbers that multiply together to equal negative 20, that when I add them, I get a negative 1. And notice that my leading coefficient is what? 1. That means that the factors that I choose over here are going to be the factors that I use in here, right? So these are the best kind of problems. Okay, so what two numbers can I multiply together to get negative 20 that when I add them, I get a negative 1? Negative 5 and 4. Nice job. Negative 5, positive 4. So x minus 5, x plus 4, with my 3 on the outside. That was good. Okay. The next one also has 3 terms, so that means I'm going to definitely have to do a times plus chart. But do I have a GCF? What is it? 8. 8x, yes. Taking out an 8x. So I'm going to write that 8x down here so I don't forget about it. When I take out an 8x, let's see, 40 divided by 8 is 5x squared. 24 divided by 8 is 3x. And negative 16 divided by 8 is negative 2, because those x's cancel. Times plus chart. 5 times negative 2, that's negative 10, adds up to 3. What two numbers can I multiply together to get negative 10 that when I add them, I get a positive 3? Lanaya. Negative 2 and 5. So that gives me 5x squared minus 2x plus 5x minus 2. Okay, so I'm going to do this little doodad right here. I'm going to move this down a little bit. Sorry, because I'm going to run out of room. Okay, so greatest common factor between 5x squared and negative 2 is just an x. That leaves me with 5x minus 2. Greatest common factor between 5x and minus 2 is just a plus 1. That leaves me with 5x minus 2. So I have the 8x, which is what I took out at the original, times the repeated factor, 5x minus 2, times my last factor, x plus 1. Question. Does the order that I put these into the problem make a difference? No. And I'm just going to show you because typically my brain tries to group them by like factors. So typically I would have put the 5s together, but sorry, I know that's a 5x, but I didn't want to do that because I wanted to put them in exactly the way that Lanaya gave them to me. But I want to show you that you still get the same result. You can take out a 5x, that leaves you with x plus 1. You can take out a negative 2, that leaves you with x plus 1. So I still have the 8x that I took out originally times x plus 1 times 5x minus 2. So I just want to show you that the order that you put your factors in doesn't matter as long as you have the right signs on them. Does that make sense? Okay. All right. How many terms does this next example have? 3. Does it have a GCF? No, because 13 is prime. So let's see. Times plus. And we had a same kind of numbers in our homework. It's actually still on the board. So 6 times 6 has to equal 36, and they have to add up to a negative 13. So what are my two factors? Yeah, negative 9 and negative 4. Good job. So 6a, we actually have an a squared and everything, right? We're going to take out an a squared. I lied. Okay. So that leaves me with, let me erase that. So it leaves us with 6x squared minus 9x minus 1x plus 6. God bless you. So GCF in the first parenthesis, what can I take out? 3x. That leaves me with 2x minus 3. The next parenthesis, what can I take out? I feel like I'm doing something. This is a 4. Sorry. I couldn't even read my own writing. That's a 4. Sorry, guys. So what can I take out of this second set? Notice that my leading coefficient is negative. A negative 2. Good job. Let's see. Negative 4 divided by negative 2 gives me a positive 2. Positive 6 divided by negative 2 gives me a negative 3. So I end up with a squared times 2x minus 3 times 3x minus 2. I'm pretty certain that that was one of our factors from the page 13 exercise. Okay, so for this last one, I'm just going to tell you right now, you're going to need lots of space. Let me be real specific. Let me look at mine and see how much lots of space look like when I get it. If I can find it. Lots of space looks like. Okay, here we go. 1, 2, 3, 4, 5. I used 6 rows to not true. I used 5 rows to group my thinking. Okay, so we'll write small, get skinny. I don't know what else to say. Here we go. So this is the difference of what? 2 squares. So when you have a exponent that's positive, you know that it's this perfect square. And to unsquare it, you just divide it by 2, right? So this is the same thing as m to the power of 16 plus 1 times m to the power of 16 minus 1. Okay. So any of the plus factors we can't reduce, but all of the minus factors we'll be able to reduce. So the m to the 16 plus 1 is going to stay the same, but how do I break down m to the 16 minus 1? That 16 divided by 2 is what? M to the 8 plus 1 times m to the 8 minus 1, right? Because when I multiply, I add them. 8 plus 8 is 16, so that works out. So now I'm going to write my m to the 16th plus 1 times my m to the 8th plus 1. But I have to break down, I have to factor again the m to the 8th minus 1. Well, that becomes m to the 4th plus 1 times m to the 4th minus 1. I always try to put my minus last when I have a big term like that, so I'm always just refactoring the last term. So again, I have m to the 16th plus 1 times m to the 8th plus 1 times m to the 4th plus 1. But that m to the 4th minus 1 breaks down to, yeah, m squared plus 1 times m squared minus 1. Okay, we're almost done. So rewrite all your positives. So I have m to the 16th plus 1 times m to the 8th plus 1 times m to the 4th plus 1 times m squared plus 1. And m squared minus 1 becomes m plus 1 times m minus 1. Okay. So so that's the end. That's our last example, but I'm going to tell you something. We're going to take a quiz over factoring on Friday, a factoring quiz on Friday, and I will give you +2 extra credits on your quiz if you can foil this to show it started as m to the 32nd minus 1. That means I need to see every single step. I did it. It took a whole piece of paper because I just thought it'd be a cool extra credit. Sorry. So it really only took a half sheet of paper. Does that make sense? And it's really not going to be FOIL. It's going to be just distributive. So you're going to have to check this. You're taking this answer and you're going to check it to make sure it comes out to be m to the 32nd minus 1. Does that make sense? Okay. If you don't show all your work, you don't get the points. Okay. So let's talk about homework. I'm going to stop the whole